Okay, so this problem is one on page 3. There's binomials and trinomials on page 3. If you need to see one of the trinomials, go to the video on page 4. But with binomials, so two terms here, with these binomials, the only way we can factor this is by if we have a difference of squares. So difference, again, means subtraction. So if we have a subtraction, which we do here, we have subtraction. What I want you to realize is if this was written as negative 49 plus 4n squared, the other order, realize you could switch the order to turn it into a subtraction instead. And then the other part is we have to have what are considered for both of our terms to be perfect squares. Remember, perfect squares, 1, 4, 9, 16, because they have a number times itself or a value times itself that equals that number. So if we're looking at 4n squared as a perfect square, well, you say what times itself equals 4n squared. Well, that would be 2n times 2n. 49, perfect square because 7 times 7. So the pattern for perfect squares, and this is your general formula for difference of squares, a squared minus b squared equals, it's a plus b times a minus b. So a and b would be like those square roots. A squared is a times a. B squared is b times b. It would be those roots, or what times itself gives me that initial term. So 4n squared minus 49 factored is each of those components 2n and 2n in the parentheses, and then one is plus 7 and one is minus 7. Because if you recall, and so this is our solution or our factoring, if I go through and I multiply those 2n plus 7 and 2n minus 7, if I FOIL those out, 4n squared minus 14n plus 14n and minus 49, the reason I have to have one plus and one minus is look what happens to those middle terms. Negative 14n, positive 14n cancel out, and I FOILed to get a binomial. So to match the answers here, in case you're confused how the puzzle works, you find one of your values in one column, one of your values in the other column. So what that's telling you is in space 9, you place a G.